Evaluating logs. So recall, we have this definition, y equals log base a of x if and only if a to the y equals x. So this is how we have defined a log. What do I mean by that? If we want to figure out what log base 2 of 16 is, we can use this basic, we can use this definition here. How do we do that? Well, log base 2 of 16, it equals some y value if and only if, that's my abbreviation for if and only if, 2 to the y is equal to 16. In other words, if we want to know what log base 2 of 16 is, what we're really trying to do is we're trying to figure out what y would you raise 2 to in order to get 16. So 2 to the what is equal to 16. So let's think about it. If we do 2 times 2, we get 4, times 2 is 8, times 2 is 16. So we know that 2 to the 4 is 16. This tells us that the number that goes here is actually 4. In other words, if we want to evaluate log base 2 of 16, we should get 4. Let's do a couple more examples. Find the logarithm. In other words, find log base 3 of 1 over 9. So what are we being asked? We want to know 3 to what power gives you 1 over 9. And that's by definition of how logs work. You can call this output question mark, or you can call it y, or you can call it whatever you want really. So I often write question mark, but you can also call it y because that's your y value. So we want to know y equals what? Well, if we want to get a fraction here, this power is going to have to be negative to get a fraction here. We know that 3 to the 2 is 9, right? If we want the 9 to be on the bottom, we're going to have to raise 3 to the negative 2. Let's check that really quick. 3 to the negative 2 is 1 over 3 to the 2, which is in fact 1 over 9. So the answer to this problem is negative 2. In other words, log base 3 of 1 over 9 is equal to negative 2. Negative 2 is the number that you would raise 3 to get 1 over 9. Let's try another one. Log base 1/2 of 1 over 32 is equal to what? So here's how I do these problems. I write log base 1/2. Well, actually, usually what I do is I write, okay, this is equal to something. I call it question mark or y. And then I think, okay, we want 1/2 to the something, question mark, equals 1 over 32. And then I just need to think about how many times do I need to multiply 1 over 2 by itself in order to get 1 over 32. Now, you can do it by hand on the side and start doing, okay, like 1/2 times 1/2 times 1/2 and see how many times you have to do it to get 1 over 32. So 2 times 2 is 4, times 2 is 8, times 2 is 16, and then we just have to do it times 1 more 1/2 to get 32. So we have to do it 5 times. So our answer here is 5. And that's exactly because 1/2 to the 5 equals 1 over 32. Okay, let's do a couple more. Find the logarithm. Log base 7 of 7 to the 1/2. So for this one, we want to know 7 to the what, we'll call it y this time, is equal to 7 to the 1/2. So this is a little strange. Now, if we're looking for the y that you would raise 7 to get 7 to the 1/2, our answer is actually right there. If both of these bases are 7, then the exponents would have to be the same. So this means that y would have to be 1/2. In other words, log base 7 of 7 to the 1/2 is just 1/2. Now I want you guys to notice something kind of interesting. So notice that if I did log base 7 of 7 to the 1/2 and I got the exponent right here. That's actually going to happen every time you have a similar situation. So for example, if you have log base a of a to any power, the answer is always going to be that power. So here's an example. If I did log base 11 of 11 to the 22, the answer is just going to be 22. Or if I do log base 2 of 2 to the 5, the answer is just 5. And that always happens. Let's try to use this fact in part B. So let's look over here. We want to figure out log of 1 over 100. Now we know that log is the same as log base 10, right? We know that's log base 10. I'm going to write it like that just to remind you guys. Now if I can write the inside here as 10 to a power, then I can use this property like right here that shows you that you can kind of like think of this as like canceling out and giving you the answer. So can we write 1 over 100 as 10 to a power? Let's see. I can write it as 1 over 10 squared, because 100 is 10 squared. And then I can write it as log base 10 of 10 to the negative 2, because if I want to move this exponent, if I want to move 10 to the 2 to the top of the fraction, I can do that as long as I make the negative the exponent negative. That's an algebra property. And from here, I can think of these as like canceling out. So these, you can think of them as canceling out, and then you get the answer is just negative 2. Based on this property that says that log base A of A to any number equals that number. Okay, let's look at a couple more examples. Now, remember, the natural log is log base E. So recall, ln of x is the same as log base E of x. Now we just saw that if you have log base A of A to the W, that's always equal to W. It's going to be the same thing for log base E. So if I do log base E of E to the W, that's W. But we don't usually write log base E. We always write ln. So instead of log base E, I would write ln. And so we have this extra property that's really cool, which says that if you ever do ln of E to a power, it's just equal to that power. So if I want to figure out what is ln of E to the 8, it's actually just equal to 8. And that's it. Okay, let's look at B. This is a little bit different. So not only do we have the property that ln of E to the 8 is 8, but if you do E to the ln of something, it's actually always equal to whatever's in the exponent as well. And that has to do with the fact that E and ln are inverse functions. So recall, f of x equals e to the x, and f inverse of x is ln of x. So like the e to the x function and the natural log function, they're inverse functions of each other. So this means that if I were to do, let's see here, f of f inverse of x, I'm going to get x back out, property of inverse functions. So if I stick the natural log function inside the e to the x function, I always get x back out. So if I stick the natural log function into the e to the x function, I get x back out always. So this here is a property of e and natural log. In other words, if I ever want to find e to the ln of a number, what comes out is just that number in the exponent. And this is true because e and ln are inverse functions of each other. Okay, let's do one more example. We're going to evaluate ln of 1 over e to the square root of 2. Now, if we rewrite this a little bit, so if I rewrite this as ln of e to the negative square root of 2, I can actually figure out what the answer is because I know that ln of e to any power is just equal to whatever that power is. So this is exactly equal to negative square root of 2. Now I was able to see this by rewriting the inside of the natural log as e to a power. It's very important that you know this property and the property that says that e to the ln of x is equal to x. So we're going to use those pretty frequently.